This lecture is a lab demo where I'll compare our distance vector and our link state routing protocols. So it's the same lab topology we've been using for the last few demos. I've got routers R1 to R5, and this is continuing on from the last demo where we already had RIP set up and configured. So let's check that. So I'll go on to R1 here. Now the command to check which routing protocols are running is show IP protocols. So I do that. You can have multiple routing protocols running on the same router, but it's usually not a good idea to do that. Here I can see that the routing protocol, I'm only running one, and it is RIP. To check the configuration, I could do a show run and then scroll all the way through my configuration until I get to the RIP section. But you see here, even on a router without much config like the one I have here, it can be a bit inconvenient to find the section. So a couple of easier ways of doing this, I can do a show run and then use the pipe symbol and then say section RIP. And it will just show me that part of the running config. So it's a lot more convenient. Another way you can do it is show run and then pipe it and say begin RIP, and it will begin the running config output where it sees that string of RIP. So that will take me to the correct place as well. So you can see here I've got RIP configured on here. And to see the information that was received from RIP, I can do a show IP RIP database, and that will show me all the routes that were learned from the neighbors. So with our routing protocols, there's really three things that happen. The routers will form an adjacency with each other. I'll talk about that more later. They then will exchange routes with each other, which will go into the routing protocol database, and then the best routes will make it into the routing table. And to view, so show IP RIP database is how I can see the database. To see the routes that are best that made it into the routing table, I can do a show IP route, and I can see my RIP routes in there. Okay, so if I scroll back a little, you can see with the show IP RIP database, remember RIP was a distance vector routing protocol. It uses routing by rumor, so I just get information from neighbors as far as the neighbor's point of view is concerned. Okay, next thing I'm going to do is to configure OSPF on here. So I'll go to global configuration. Again, don't worry too much about the config yet because we'll cover this in more detail when we get to the OSPF section. I'm going to say router OSPF 1. And then network is 10.0.0.0, and it uses a wildcard mask, which is the inverse of a subnet mask. So that is 0.255.255.255. That's equivalent to a subnet mask of 255.0.0.0, meaning I want to enable OSPF on all my interfaces which have got an IP address that begins with 10. I don't care what the other octets are. And you see it's giving me the error message incomplete command because I forgot to specify the area. I'll say area 0. Don't worry about the areas yet. We'll cover that when we get to OSPF. Okay, so that was on R1. I need to do it on all of my other routers as well. So I'll do a config T on R2 and say router OSPF 1 and then network 10.0.0.0 and 0.255.255.255 area 0. I'll also do it on R3. Let's do this quickly for you. Router OSPF 1 network 10.0.0.0 0.255.255.255 and R4 config T router OSPF 1 net 10.0.0.0. I can just put in the same command in every router because they've all got networks that begin with a 10. And remember to put the area in as well, and just one more to do. So R5 config T router OSPF 1 network 10.0.0.0.255.255.255. You remember in the last lab demo, I used a text editor to copy and paste. You can see the benefit of it there. It was quicker when I used a text editor. It's more convenient, and I made a couple of typos. Like I did it again. I keep forgetting to put the area in. If you use a text editor, that's another benefit, that you're not going to make any errors. You're not going to have any typos there. Okay, so that is OSPF configured. I can see the OSPF adjacencies coming up. So now if on my router here, I do a show IP OSPF database, and I need to do this at the enable prompt or put the do in front. So I'll do that. You can see the difference is that I'm seeing link information in here. So the router here, R5, it learns about all of the other routers in the area, and it learns about all of the links on those routers as well. And if I went on to R5 and did the same command on here as well, a show IP OSPF database, it's going to have exactly the same information. So it does not get updated from the neighbor router's point of view. All of the states of all of the links of all of the routers in the network get shared the same between all of the routers in the area. So the routers have a more complete view of the network with our link state routing protocols. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.